Hello everyone, what's up? In this video we are going to look at the problem F from the Codeforces round number 667, which was held 4 days back. I could not solve it during the contest. Today I decided to upsolve it and share my approach with you guys. The problem is called Subsequences of length 2. So we have been given two strings S and T. The length of T will be exactly 2 in all the cases, and both of them are consisting lowercase Latin letters, and we can perform at most k number of moves, and in any move we can choose any character of S and replace it with any other lowercase Latin letter. More formally, you choose some I and replace SI with some character from A to Z. Okay, so what is our aim here is we want to maximize the number of occurrences of T in S as subsequence. So this is a main thing here. We want to maximize the number of occurrences of T in S as subsequences, and yes, that's all for the question. And for the problem statement, let's see the constraints. It is a hint. It will give us a hint that we can use dynamic programming to solve this problem, as the length of S can be at most 200. So if the length of S is at most 200, we can at most chain 200 characters. So k is also less than equal to n. And let's see the first example here, which is here, in which n is to 4 and k is 2. S is given as BB, BBAA, and AB is our T. So we want this to occur as many times in this string S as subsequences. So if you are, I am assuming you are familiar with subsequence. In subsequence, the characters need not be consecutive. They can occur after, like there can be multiple characters in between the consecutive characters of subsequence. For example, in CP edict, even C and DD, CDD is a subsequence, and even CAI is also a subsequence. What we can do here is, as we can perform at most 2 operations, and we want AB to occur as many times as possible as subsequence in S. What we can do, we can change this B to A and change this A to B. Then our resultant string will become AB, AB, AB. So if you see the number of times AB is occurring as subsequence in this string would be this 1, 2, and 3. Yes, the output is 3 in this case. So let's see what we can do to solve this problem. Now I handled the case where T0 is equal to T1. I handle it separately, that is if the string S is containing similar characters, that is AB, BB or CC or ZZ, that is the characters are same. In this case, if you observe, suppose we have a given string ABC, 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 and we want to find out the maximum number of times this double A is occurring in this string as subsequence. Then those would be this 1, 2, and 3. There are only 3 cases, and there were 3 A's in it. And suppose if we are having the string S as this, then the number of times this string A is occurring as subsequence in this string would be 1, 2, 3, 4, 5, 6, 7, and then 8, 9, and 10. And the number of ones here are, number of A's here are 5, and here it was 5. So if you see, the result is, if we are having x number of A's in it, that is the character in T. And if we are having the same character at both of the places in T, if we are having X number of A's, then the number of possible subsequences of that string inside the S string would be X minus 1 plus X minus 2 and 2 plus 1. That is the sum of first X minus 1 natural numbers. This would be the answer. In this case, if we are having T0 equal to T1. So in this case we had 3 A's, so the answer is 2 plus 1, it comes out to be 3. Here we are having 5 A's, the answer is 4 plus 3 plus 2 plus 1, it is 10. Okay, so in this case our aim should be to maximize the number of occurrences of A. Here I am only considering the case A. A can be replaced by any character from B to Z depending on the character present in our string T. We are considering A's. So we want to maximize the number of occurrences of A in our string S. And suppose our string S looks something like this. If we are having a A in string S itself, then we do not need to change that. As why do we change it and perform operation as we want to? Because we can use that operation to change some another character to A. It will be helpful. It will increase our answer. So we won't be changing these A's, as these are bonus. These are bonuses we are having, and we can change other characters, any other character to A's. We can perform K operations. Suppose K in this case is 3. We are having K in case. So the other characters, which are these ones, we can change any K of them into A. And so previously we were having 3 A's which are already present in our string S, and then we converted 3 more characters into A. We can change any 3 of them, the remaining characters, into A's. So ultimately we would be having 6 A's. Then the answer would be the sum of first 5 natural numbers in this case. And it does not matter which characters we are changing, because we only care about the A's, and we want to consider the subsequences. Just to give you one example, suppose we have this string and our T is AA. We want to maximize the number of occurrences of T occurring as subsequence in this string S, and we can only perform one operation. Suppose this is the example. So we can change any of these 3 into A. The answer would be 1 in all of the cases. It does not matter which character we are changing. If you realize, if we change S, then this would be our answer. If we change B, this would be our answer. And if we change C, this would be our answer. We only care about subsequence, and this is also a subsequence. So okay, till at this point we have covered the case when T0 is equal to T1. Now let's see the case when T0 is not equal to T1. So the characters of T are different, like A, B or C, E, whatever. Okay. Now we would be solving it using dynamic programming. I hope you are aware with dynamic programming. So whenever we are solving a problem using dynamic programming, we have some states in our function. I would be solving it using a recursive program. So we have states. States basically means what are the things which on which our answer depends, or our current processing depends, so that we can move ahead with our recursive calls or calculate the answer. Like we can move ahead to calculate the answers for sub problems, and then use the answer which we get from sub problems and build the solution for the current problem, which is the bigger one. And yep, this is the main thing. So if we are solving it using dynamic programming, what are the things which we need to consider if we are building a dynamic programming solution? And we would be traversing the string S from left to right. Okay, so things which matter would be index, that is at which index we are currently at in string s. One is index, and the second would be remaining case, that is remaining number of moves, how many more moves we can perform. Okay, and the third thing which we would be considering is number of occurrences of first character before this index. These are the three things which would be varying, or which on which our solution depends. Range of this is 200, also it is also 200, and the maximum number of occurrences of first character at any place can be at most 199. Let's say it is 200 because suppose we are at the last index, it can be at most 199, and we had 199 characters before this one, so at most we can have 199 A's or first character T0s before this one. So our DP array would look something of this size, and it is manageable to solve this problem. Now see what, let me again explain what this occurrence first is. Suppose we are, this is our string s, we are traversing it from left to right, and we are at this place, at this index, and yes, so, and suppose our T0 is equal to s, then at this index we have the value of index, we know about the remaining number of operations we can perform. Okay, and what about the first occurrence? It is basically, it tells me how many times the first character in T, that is T0, here we are considering it as s, occurred before this index, and we have been processing this along our recursive function or along our dynamic programming solution. If suppose this is the string which we are currently building in our current recursive function call, then we see that the value of this occurring first would be 2, as we have only seen s 2 times before this index. And if we had if we were at this index, that is the second s, then the value of that the occurrence first would be 1, as before this index I have only seen for s only one time. Okay, so that's all for the states we would be having in our dynamic programming solution. Now let's see the cases. Suppose our remaining number of moves is equal to 0, that is we cannot perform any further moves. And yes, one more thing, suppose we are having x number of T0s before this index. So we are having, suppose our string is T is AB, so we are having x number of A's before this index, and if this at this index we are having the character as B, which is T1. So using this B, we can have x more number of subsequences, that is we would be using each of these x's, each of these A's, and there are x A's before this index, and we would be combining all of those x A's with this B. So we would be having x times AB. So the answer, it would be contributing x to our answer if we are having x T0s before this index, and at this present index, at this current index, the character is B, which is T1. This is T1, and we are having, so yeah, I explained it I guess. So yeah, let's move ahead with the solution. So if remaining is equal to 0, that means we cannot perform any more number of moves. We would be seeing what is the current character, and we are having T0 and T1, which are the two characters of our string s. So if we see, if s of idx is equal to T0, then this current index would not be contributing anymore to the answer, as we cannot build a new substring of it. But as the current one is T0, so we will move ahead with a recursive call, and that is idx plus 1, remaining would remain the 0, and we will increase the number of number of occurrences of first character, that is t0, by 1, as even this current character is t0. So for further calls we have incremented it by 1. And in the other case, if idx is equal to t1, it means it is the second character of our t. Then we would be seeing how many number of t0s we have seen before this index. And if we had seen x number of t0s before this index, then using those x t0s we would be having x more subsequences using this t1 and x more t0s before this index. So we will simply add x to our answer, plus we will move ahead with a recursive call idx plus 1, remaining would remain with 0, and the number of occurrences of first character would also remain same, as this is t1. It won't be contributing to the number of occurrences of t0s. And in other case, when s of idx is not equal to t0 and also it is not equal to t1, in that case this current index does not really matter to us. It won't be contributing anything to the answer. We will simply move ahead with a recursive call idx plus 1, and the other two parameters would also remain the same. Now for the second case, when we are having some remaining number of moves, so in this present character we have two choices, whether either we can change the current character or we cannot change, we won't be changing it. And the answer, suppose we are getting from changing the current character to something, yes, we can change it into a or we can change it into b, that is t0 or t1. And suppose we are getting answer 1 from this case and answer 2 from this case, then, and if we are not changing the current character, we are getting answer 3 from this case. Then at the end, this solution we would be returning the max of answer 1, answer 2 and answer 3, because we are considering all three cases. That is, we are changing the current character to a, either or we are changing the current character to b, which are t0 or t1, or else if we are not changing it to any other character, we are storing its answer in answer 3, and at the end we are returning maximum of it, because we want the maximum number of occurrences we are having. Yes, and yes, if the current character is a itself, then there is no need to change it into a. We won't be considering that case. We will only change it into b. Again, I am considering t0 as a, t1 as b. I am talking about a particular case. And if the current character is b, there is no need to change it into b, as it would be costing us 1, which makes no sense, as we are having b at the first place. And we won't be doing it. We will be considering the case where we are changing a to b or b to a, or else we are not. And if the character is something else, that is, suppose it is c, then we will be considering three cases: when we are changing it into a, or when we are changing into b. The third case, when we are not considering any kind of change. So yes, enough for the explanation point of view. Let's see the code now. Yes, I have taken the input string s and t, and if I see that t0 is equal to t1, that was the particular case which I handled separately. So I called this function maximum occurring. I see. So first of all, count is storing the number of occurrences of t0s I can have, and here t0 is equal to t1. So first of all, I am traversing the string. I am counting the number of t0s which are already present in my string s. So at this point, I have that in my count variable. Now I can change the other characters into t0. So I am considering as count plus k, and taking the minimum of count plus k or n, because at most we can only have n number of t0s in our string s. Okay, then at the end the answer is the sum of first count minus 1 number of natural numbers, as I had explained. Okay, now let's move to the second case. Yes, and for the case when t0 is not equal to t1, so I'm going ahead with my dynamic programming solution. Here, if I reach to the last index, that is traverse the whole string, I'm returning 0. If I've already calculated the answer for this particular subproblem, I'm returning that. and else. Then I'm going ahead with the solution. If remaining k is equal to 0, that means we cannot perform any more moves. I see if the current character in S is equal to t1, so I can have first number of more subsequences using the current character, where first represents the number of t0s I have seen till this point. Okay, so first I'm adding the first and then going ahead with my recursive call. Number of first will remain the same. Else so I'm moving ahead with my recursive calls and going ahead. If the current character is equal to t0, then I need to add that to the number of occurrences of first character, that is also t0. So first is the number of t0s I have seen till this point, and if the current character is also t0, then I am adding 1 to it, otherwise this will return 0, so the value would be first plus 0. So yep, now this is the second case where we have non-zero remaining, that is, it is up to you. We can perform some changes if we want. So if we see if the current character is t0, then it cannot help us to get any more subsequences without any change. So if we leave it as it is, we go ahead with the recursive call, remaining one would also will also be same. No. Yep, and as it is t0, in the next call we are adding 1 to the number of occurrences of t0, as the current one is also t0. Else we can change it to b. It is up to us because we have a non-zero k. So if we change it to b, then it will contribute to our main answer by first. First is which I have seen. First is the number of t0s which I have seen till this point, and if we change the current character to b, we'll add first to our answer, then move ahead with the recursive call, and we decrement 1 from remaining case as we have used up one move. Then we are returning the maximum of it. Else if we see the current character is equal to t1, so it will contribute first to our answer, and we go ahead with the recursive function call. Else if we are changing the current character to a, because we have these choices as well, if we change the current character to a, our number of moves will decrement by 1. Also the number of occurrences of t0 will be incremented for the next recursive call. Then we are returning the maximum answer. So if we have reached to this else condition, it means the current character is neither equal to t0 and it is neither equal to t1. So in this case we have three choices. Either we can replace leave it as it is, we are not making any changes to this character, or we can change it to b. If we change it to b, it will contribute now first to our answer, and remaining number of moves will decrement by 1. First will remain to the same. Else if we are changing it to a, our moves will decrement by 1, and the number of occurrences of t0s will also increment by 1 for the next recursive call. At the end we are returning the maximum of these three cases, and yes, this is the return function. Yes, it also turned out to be a pretty long video. I like this question. It was a classic DP problem. Yep, that's all for this video. I hope you liked it. Please like our videos and share it with your friends if you are learning something from them, and do subscribe to our channel. Till then, happy coding. Sayonara.